Okay, Assalamualaikum and a very good day everyone. So for this video, we would like to do a presentation on our assignment for our group. I Mohamad Afiq, and then with my friend Daniel Syafiq, Nabil Ilman and Mohamad Aiman Zafir. For the part introduction, so basically this assignment is talk about the fertigation. So fertigation is one way of growing vegetable with advantage of minimizing amount of watering. So basically there is two common types that we use that is very functionable for watering process, namely straight line or closed loop. So these two different configuration will give variation in terms of flow rate as well as the volume of water received by each plant. So this situation later will affect the quality of the plant itself. Okay, next we'll continue with my friends.
So for my explanation is about task 1. So for task 1, we determine the maximum achievable for water jet. So I have measured the maximum water jet height, and also I have taken the time taken to reach the 10 millimeters of water in a cup, and also I have take the time taken to reach the maximum level for to fill up the 10-liter water tank, and also I have taken the time taken to reach maximum water jet. So I basically measure the time taken each of the tasks. So for this I've calculate the parameter of the result. So the result that I have is I've measured the hose pipe diameter. So the hose pipe diameter is like the end of this whole hose to I mean like we must close it by achieve the maximum of water jet. So I also measure the hose pipe length, that is 6 meter. So and also I measure height from supply X. So is the supply X is like a straight line, but in opposite direction with the Y line. So I have measured it 0.5 meters. So for the height of water jet, maximum jet from the end of the hose till the top of the which means the top of the end of the water flow is I get like 3 meters. So I also calculate the time taken to reach is to fill 10 milliliters cup, and also 10 liter tanks. And also I have taken the time taken that water jet where we have that achieve maximum water jet level. So this is the calculated parameter. So for the cross section area of the pipe, that the end of the hose is 0.452 millimeter square. So the flow rate Q I get like 4.717 millicubes per square. Velocity I get 10.44 milli per square, and also maximum pressure for the of that pressure I get 1030 755 Pascal. Okay, for for the conclusion of this part, velocity and pressure of water in pipe can be measured. So I have measured this velocity and also the pressure of this hose pipe that for the main task 1. So flow rate of the water can be also measured. So also the flow rate is I can measure using this formula on the Bernoulli, and the short results that experiment fulfill Bernoulli principle is increase in speed and also decrease in pressure. So I will give the next person to explain task 2.
Okay, my name is Nabil Ilman. For this assignment, for task 2, we're measuring the multiple water jet with different kind of fertilization water supply. As you can see, we have two types of fertigation. Okay, we have two types of fertigation, which is the straight line and the closed loop hose. Okay, for the next one. Okay, we see this for the straight line water hose, we use the 10 meter length of hose pipe, and we not using any extended hose pipe. And the diameter of hole we use approximately 0.04 meter, and which is for the measurement of cup we use 10 ml. Okay, from the data of the experiment, for the distance from main supply, we approximately use 2 meter for the each single connector hole. And for the time taken, we can see that the further the distance from the main supply, it will increase the time taken to fill up the 10 millimeter ml, which is we can see that single connector hole 1, it take 1.5 seconds to fill up the 10 millimeter cup, and and it will increase the time taken until we can see the single connector hole 5. It takes 5.22 seconds to fill up the 10 millimeter cup. So the further the distance, the longer the time taken to fill up the 10 millimeter cup. Okay, now we can see for the experiment for closed loop water hose. For this type of fertigation, we use same for length hose pipe, which is 10 meter, and for this type of fertigation, we use the extender hose pipe, which is 0.5 millimeter, and the diameter of hole is approximately same as the first one, 0.04 meter, and for the measurement cup also constant with the first fertigation is 10 millimeter. So the distance from the main supply approximately 1 meter from each single connector hole. So as we can see from the data that we get, it is slightly or almost same for each hole to fill up the 10 millimeter cup. As you can see, for the single connector hole 1, we get 4.25. The single connector 2, we get 4.28. Until the connector 10, we get 4.67. So we can see that from all the single connector hole, we can see that just slightly different time taken to fill up the 10 millimeter cup. So for the next one, I will pass to my friend Aiman Zafir.
Okay, hi. I'm Mohamad Zafir. Now I'll be talking about the CFD simulation for both configuration, which is straight line, and the closed loop configuration for fertigation. And so we can see here, for the straight line configuration, we can determine that the water flow moves in a certain pattern. So as you can see here, for x and y velocity, as it starts, the graph drops, and then it increases slightly up here, and then but in z velocity, which is the direction the water flows out, at first the water decreases, and then after a while it stays on constant. But to sum this up, we have to see the epsilon value. So the epsilon value tells that the water flowing out is constant, which is because on the first hole, when it passes the first hole, the velocity is high, but at the end the velocity is lower because there is much pressure out from the pipe. Okay, now we take a look at the closed loop configuration. We can see that as it starts, the pressure is high. As the wave starts, is high, and then it drops dramatically until the end. For x and y value, it's about the same. The pattern, and for z velocity is also the same. And at epsilon, we can see that there are some spikes here, which indicates the corner of the pipe. From here, we can determine that the flow is constant for, the velocity of flow is constant for all sides of the pipe. So to conclude, for task 2, you can see that closed loop configuration has a more sensitive detection towards changes of velocity and pressure of water in pipe. And also, closed loop provides a steady and same output throughout all holes that is made, where the velocity of water that spurts out from the hole is about the same altogether, as we can see in here. And then for straight line configuration, it has an unstable output on every hole. The velocity of liquid that flows in the pipe is higher when it is closer to the supply, but as it reaches to the end, the velocity decreases because it has been flow out from the first hole. Okay, so this task can also be related back to Bernoulli principle. The pressure of water circles back to where the water came from on the second configuration, which is the closed loop, thus maintaining the pressure on each hole and causes velocity of liquid to stay constant. So in conclusion, I can say the best fertigation configuration for a farm is by using a closed loop configuration. And that's it for our presentation. Thank you.